Good morning, science fans, and welcome to another deep dive into the remarkable events shaping our understanding of the natural world. Over the weekend, one of Earth's most powerful and closely watched geological forces reminded us why it commands such respect and fascination. Hawaii's Kilauea volcano erupted with extraordinary intensity, unleashing towering lava fountains and dramatic flows that not only transformed the landscape inside its summit crater, but also claimed an unexpected victim. A remotely operated camera belonging to the U.S. Geological Survey. In a rare and gripping sequence of events, the camera recorded its own destruction as volcanic debris surged toward it, offering scientists and the public a haunting final glimpse into the raw power of an active volcano. The eruption took place within Halemaumau crater, a deep depression at the summit of Kilauea that has long been a focal point for volcanic activity. On Saturday, December 6th, the USGS camera was positioned to monitor ongoing changes in the crater, transmitting live footage of lava movement, gas emissions, and structural shifts along the crater floor. As the eruption intensified, fountains of molten rock shot skyward, illuminating the crater with an otherworldly orange glow. These fountains, some reaching heights of hundreds of feet, hurled lava fragments and ash outward in all directions. Eventually, a wall of volcanic debris advanced toward the camera, shaking the ground and filling the air with heat and ash before striking the device and abruptly cutting the feed. What made this moment especially compelling was not merely the loss of equipment, but the scientific and symbolic significance of what the camera captured. Instruments like these are designed to operate in extreme conditions, but few are ever placed so close to the heart of an eruption that they witness their own destruction. The final seconds of footage showed increasing tremors, thickening plumes of gas, and the relentless approach of glowing debris. For volcanologists, this data provides valuable insight into how rapidly conditions can change during an eruption, and how volcanic material behaves as pressure builds and is released. Kilauea is no stranger to dramatic eruptions. Located on Hawaii's Big Island, it is considered one of the most active volcanoes on the planet. For more than 3 decades, it has erupted almost continuously in one form or another, reshaping the island's geography and offering scientists an unparalleled natural laboratory. Its eruptions are typically effusive rather than explosive, meaning lava flows steadily rather than detonating violently. However, even these gentler eruptions can be incredibly destructive, as molten rock at temperatures exceeding 1,000 degrees Celsius consumes everything in its path. The latest eruption marked the 38th episode in the ongoing summit eruption cycle that began on December 23, 2024. Each episode in this cycle has varied in intensity and duration, reflecting subtle changes in magma supply, gas pressure, and structural conditions beneath the volcano. This particular episode stood out because of the scale and consistency of the lava fountains, which were larger and more sustained than those seen in many recent events. Scientists monitoring seismic activity and ground deformation had noted signs of increased pressure leading up to the eruption, but the visual spectacle still exceeded expectations. USGS plays a critical role in monitoring Kilauea and other volcanoes across the United States. Through a network of seismometers, GPS stations, gas sensors, thermal cameras, and visual monitoring systems, researchers can track changes in volcanic behavior in near real time. These tools help scientists issue timely warnings, assess hazards, and improve models of how volcanoes function. While the loss of a camera is unfortunate, it is also a testament to how closely scientists work to the edge of danger in order to better understand these powerful natural systems. The destruction of the camera also highlights the unpredictable nature of volcanic environments. Even with decades of experience and advanced technology, volcanoes can still surprise researchers. Lava flows can change direction suddenly, collapses can occur without warning, and debris can travel farther than expected. This is why many monitoring instruments are designed to be expendable, placed in high-risk zones with the understanding that they may not survive. The data they collect before being destroyed can be invaluable, often capturing moments that would be impossible or too dangerous for humans to witness directly. Beyond the scientific community, The eruption captured the attention of people around the world. Images and videos of Kilauea's lava fountains spread rapidly across social media, reminding viewers of both the beauty and the danger inherent in volcanic activity. For residents of Hawaii, Kilauea is a familiar presence, deeply woven into cultural traditions and daily life. Native Hawaiian culture regards volcanoes with profound respect, often viewing them as living entities connected to powerful deities. The ongoing eruptions serve as a reminder of the dynamic forces that created the islands themselves. Despite its intensity, the latest eruption remained confined to the summit area, posing no immediate threat to nearby communities. USGS officials emphasized that there was no indication of lava flows moving toward residential areas, and air quality impacts were being closely monitored. Volcanic gases, particularly sulfur dioxide, can pose health risks when carried downwind, but conditions during this episode remained within manageable levels for most populated regions. Continuous monitoring ensures that any changes in risk can be communicated quickly to local authorities and the public. From a broader scientific perspective, each eruption of Kilauea contributes to a growing body of knowledge about how basaltic volcanoes operate. Because Kilauea erupts frequently, it allows researchers to test hypotheses, refine predictive models, and study processes that occur deep beneath the Earth's surface. The interaction between magma chambers, volcanic conduits, and surface vents is complex, and events like this provide real-world data that cannot be replicated in a laboratory. The footage captured by the ill-fated camera, even in its final moments, will likely be analyzed frame by frame to extract insights into lava dynamics and debris movement. The eruption also serves as a powerful reminder of the balance between observation and risk in scientific exploration. Modern technology allows us to place cameras, drones, and sensors in environments that were once completely inaccessible. These tools extend human vision into dangerous realms, capturing data that enhances our understanding while keeping researchers at a safe distance. However, nature ultimately sets the terms, and sometimes that means sacrificing equipment in pursuit of knowledge. As Kilauea continues its long and active life, scientists will remain vigilant, watching for signs of change and learning from each new episode. The volcano's persistent activity underscores the fact that Earth is not a static planet, but a constantly evolving system driven by internal heat and tectonic forces. Events like the recent eruption are not anomalies, but expressions of the processes that have shaped our world over billions of years. In the end, the image of a camera filming its own destruction inside a volcanic crater is both dramatic and symbolic. It represents humanity's desire to observe, understand, and document even the most powerful forces of nature, knowing full well that there are limits to what our tools can withstand. Kilauea's latest eruption may have consumed a piece of equipment, but it also delivered a wealth of information and a striking reminder of the awe-inspiring power beneath our feet, at a safe distance. However, nature ultimately sets the terms, and sometimes that means sacrificing equipment in pursuit of knowledge. As Kilauea continues its long and active life, scientists will remain vigilant, watching for signs of change and learning from each new episode. The volcano's persistent activity underscores the fact that Earth is not a static planet, but a constantly evolving system driven by internal heat and tectonic forces. Events like the recent eruption are not anomalies, but expressions of the processes that have shaped our world over billions of years. In the end, the image of a camera filming its own destruction inside a volcanic crater is both dramatic and symbolic. It represents humanity's desire to observe, understand, and document even the most powerful forces of nature, knowing full well that there are limits to what our tools can withstand. Kilauea's latest eruption may have consumed a piece of equipment, but it also delivered a wealth of information and a striking reminder of the awe-inspiring power beneath our feet,